Hey, so I wanted to talk a little bit about how to interpret what we have here in 6.2. All right, and this is in the book, in the exercises for 6.2. And if you look at the answers, for example, if we're going to just take a look at number 47 here, if you take a look at the answer for number 47, it's zero point 0.7. And it's asking you to estimate, and it's like, okay, well, what do we estimate? All right. And this just comes down to recognizing the circular functions, all right, and how they apply. All right, so what are the circular functions? Well, we have cosine of s, which is an arc length, or it's in radians. All right, this is going to be equal to the x coordinate. And then we have sine of s, which would be equal to the y coordinate. So when it asks us, all right, what about cosine of 0.8, 0.8? Well, we need to find the location in radians around this graph, which correspond to sort of 0.8 radians in rotation. And that space is going to be right here. All right. So there will be a triangle that's made from the origin that connects to that point, and that will be our the hypotenuse of a triangle. All right, so from the origin out to that point, it's the hypotenuse, and then making up the other two sort of lengths of a triangle, we're going to have what represents the y coordinate. If you watch my video on 6.2 and unit circle concepts, this should look a little familiar to you. Then you have another leg which extends from the origin, and this creates a right angle here. So let me actually make that blue. This creates a right angle here. All right, so the ordered pair that is attached to this point on the unit circle has something in common with this triangle. The x coordinate, all right, whatever that distance is, will be, so let's say that this is, say that's x sub 1. The coordinate at that point, 0.8, will be x sub 1, comma, now what is the length of the sort of y leg here? That's going to be y sub 1. All right, so just keep that in mind, and let's just kind of estimate what those two values are. Okay, so it wants cosine of 0.8. We're looking at cosine of 0.8. We need to use the horizontal axis. So what I can see from this horizontal axis is that's 0.2, that's 0.4, that's 0.6, that's 0.8. But what we notice is our sort of horizontal line stops there in between 0.6 and 0.8. So we're going to estimate that cosine of 0.8 is going to be equal to 0.7. All right, which corresponds to what you see here in the, over on this side in the answer key. All right, if we did the same thing with, let's say, sine of 2 radians. So this time I'm going to use, let's use a different color. We'll use brown. So where's 2? 2 is right there. And in fact, let's just use purple. 2 is right here. All right. So there is a triangle. That you can create. And now we will use, let's use blue. All right. Actually, we'll use the brown again. Now we can create those legs of the triangle. Oh, I'm drawing. Thank you. create those legs of the triangle now that my iPad is responding. I'll just draw that one in. I'm tired of fooling with it. And you'll notice we have another right angle there. So the coordinates of this point here are going to correspond to the vertical and the horizontal legs of this right triangle here. All right, so we're looking at this point, and we need to estimate the length of these legs. So sine of 2, all right, sine of 2 needs to be something substantial. So if we go to our tick marks here, let's use red. So we're at 2, 4, 6, 8, and that's 1 there. But if you notice, the line of our sine stops in the middle there. So we would estimate that sine of 2 using this chart is going to be equivalent to 0.9, and that corresponds to what you see over here for the answer for 49. So this will help you with what's going on here. And another thing to just keep in mind is, what is your input and your output? Well, your input would be the amount of radians, rotation. The output will be these coordinates. So when we come down here, it says a positive angle whose cosine is negative 0.65. All right. Well, you know, if cosine is going to be a negative, it needs to be sort of along this axis here, because it's an x-axis sort of situation, right? But then also, we're talking about this. This is an output, so this is a coordinate. So we need to go on the x-axis to negative 0.65 and see what angles can correspond to that. All right, what positive angle would correspond to that there. All right. So let's go out there and just kind of see what we have going on. So this is 2, 4, 6. So we're right about there. All right, and we need to find a positive angle that can create those two. So we can technically just take a line. I don't know how well this is going to show up on your OneNote, but we can just take a line and let's just extend it straight up. And we'll use the lasso tool to align it a little better. All right, and then we'll extend it. Okay. So what it looks like is each of these tick marks is 2/10. All right, so this is past 2. So this is like 2, but not quite 2.2, but not quite 2.3 yet. All right, so let's say 2.25 maybe. So maybe this would be 2.25. And then there's another one down here at what looks like 4. So if we look at, we'll look at number 53 here, because that's what we're working off of. The answers that are in the back of the book are 2.3 or 4.0, and it's really close to what we have here. All right, so that's, they say 2.3. Maybe saying if you look, the line isn't perfectly vertical. It doesn't match up with the grid very well. I imagine if I shifted it and made it match with the grid, it would be even better. But even, again, these are about estimates. All right, so hopefully this video helps you navigate this type of problem and just really drives home the concept of our trig functions having inputs. Having inputs and then being equal to whatever the output would be. All right, same with cosine. Cosine of our inputs are equal to the output there. So just recognizing whether or not you're dealing with an input or output will just kind of help keep you on track. Hope you enjoy. Peace.